Hey, and welcome back to Gaming for Tokens. I'm Marshall, and in this episode we're going to pick up right where we left off again, and keep talking about this trajectory calculator stuff. So, in the last video I talked about the actual trajectory calculator script that I have, this guy right here. This guy builds the arches for me, and yeah, kind of how all this stuff works and how all the collision works, and how this whole for loop here is what creates the arc for me. Based off of gravity, drag, and power. Yeah, and in this episode we're going to be talking about the controllers and the projectiles, how I get input driving those calculations, and how I get a projectile moving along them, because those are very important. If I can't get to the projectile part, I'll cover that in another video after this one. But today we're going to be talking about, or in this video we're going to be talking about the controller script, which is this guy here. So again, we have a debug, we have a display, we have a mouse button input, and all that stuff. This stuff I talked about in the last video. Yeah, and let's look at the script. So that would be this guy. And again, we have our public variables here, and in the private variables that I have are an anchored bool, anchor position, anchor direction, anchor dist, and my calculator, my local variable connection store for my my calculator. I should probably re-say that. It is a local variable that I use as a bridge between this script and the other script to be able to have these two things communicate. It is a one-way connection, but it is a connection. So this is, yeah, this will make sense when I explain everything, I promise. So this is anchored, I'm using that to see if I have clicked and dragged. So if I am currently holding down the mouse and I am dragging away from my button, right, then this is going to be true. If I'm not doing that, then it's false. My anchor position is where I started off, so that's the position that I clicked on before I started dragging. The direction is the direction from where I started to where I am currently. So when I click and then drag away from that position, the direction from where I clicked to where I currently have my cursor. And then the distance is the distance between those two things. I need all these separately because I need to feed them into the calculator separately, right? Because this guy's going to translate to power, this guy's going to translate to direction, and I need this thing to be the basis for how do I drive those other two. Yeah. So we're going to start, on start we want to get the trajectory calculator, and if we can't get the trajectory calculator, then I want to disable this entire game object. I don't want the controller to function unless I have a calculator attached to it. I could have done a fancy thing here where I did the whole this game object requires this other game object to function. There is a line of script that I could attach for that. I didn't. Chalk it up to being lazy, I guess. I don't know. But there is a way to do that up here. I think it's like a system, or it's, what is it? It's like a component requires type of or something. Component ENT requires, I don't know, yeah, I don't know. I don't remember how to do it. I could look it up, but I would waste your guys' time. There's a way to do that, and it's a required type of. If you want to look that up in the Unity script database thing, the scripting reference, then look up required type of, and it should come up. And you could put that here instead of doing this, but I like to do this because it gives me an error instead of just... The required type of means that when you attach this object, it'll attach the other object for you, and if you attach the other object first, it doesn't care. So it's kind of handy, and it kind of roundabouts this whole process, but this actually tells me what I'm doing wrong instead, and it's kind of nice. I don't know. It keeps me in check, rather. So yeah, that's kind of what I'm doing here, and this dot enabled actually, that controls this checkbox up here, this one right here. So that'll actually disable this whole thing instead of messing with all the other stuff I have going on. It'll just disable the script on this object. Cool. So right into my main loop on this guy. On update, if we're anchored, so if we're actually doing something with this, so if we've clicked and we've dragged, then we want to see if we get the mouse button. So this is a input for if we're currently holding down the mouse, this will be true, and the mouse button this stage takes an int value, right? So this is the int value that we created up here at the top for which mouse button we're using. In my last video I changed it to 1 and it worked with right click. Mouse buttons are just something you have to learn, but basically 0 is left mouse, 1 is right mouse, and then 2, 3, 4, 5, 6, 7, 8 I believe. I think it just goes up to, I don't know how many it goes up to. I believe it's whatever your mouse inputs are. So I guess it's 99 or something, or maybe it's probably something like 256 or something like that. But yeah, you can look those up in Unity, or if you just look up mouse button numbers, I'm sure you'll find exactly what you're looking for. But basically, left and right click is 0 and 1. You shouldn't really need to do anything past that. I think 3 is actually the center click. So like if you click in your scroll wheel, I believe that's 3. But yeah, so I just have that here so I can change it on the fly if I need to. If I need to change my inputs, I can just do that. Yeah. So if that mouse button is down, whatever mouse button we've specified, then we're going to want to start doing some stuff. We're going to start gathering some information on what's going on. So our anchor direction is going to be again, normalized, so the direction from our anchor position, so where we clicked, to our current mouse position. And I know that if you're thinking about how I did this, you have no idea how any of this started, because I haven't done any of that. I haven't done any of this stuff yet. So anyway, just pretend that I've clicked and all that is magically working. And I'm starting to drag away. So this is going to be the direction that I'm going from the point that I clicked to where my cursor currently is. Now the distance between that is going to be the vector3.distance from the mouse position to the anchor position. That's fairly straightforward. Now this is actually going to be where we set that stuff, set the information we've gathered into our calculator. The tcalc power is going to equal a clamping of our distance based on our input power. We're going to multiply that by our input power, which again, remember in the last video I talked about how a 50 pixel distance isn't very much, but that translates to 50 power directly if we just feed that in, and that's bad. So we want a multiplier on that to be able to kind of bring it down. We want that input to power to be not 1. Jeez, not 1. We want that to be, what is it? I have it set to 0.05. So let's change the default on that to 0.05. And it's important to know, actually this is a really, really important note. This is one of the flaws in my system. This whole controller is based off of pixels. So if the screen is smaller like this, it will actually feed in less power as I move farther away. So I can actually move farther away before it hits the maximum power threshold, which is 2. So like for example, I'm this far away from the object and I don't have max power yet, but if I increase the size of my window and I get that same distance away, I've already hit max power right here, right? So it's the number of pixels away, which makes it kind of a pain to adjust for the size of the object. And there are ways around that, but I'm going to leave that up to you guys. Sorry, it's just that it's really, really messy for me doing a demo of how to do an arc. The controller here was just to show you how the inputs worked. You can do the cleanup work on that part. I have confidence in you, I promise. But yeah, so that's the distance there, and that's this guy right here. The input.mouse position is in pixels, and so is the anchor position. When I get that is the input mouse position. So if we wanted to do something there, you could just multiply that based off of some sort of value that you determined from some scalar, right, for the pixels. Anyway. So yeah, we're gonna take the anchor distance and we're gonna multiply that by the input to power multiplier that we have, and we're going to make sure that it doesn't go below 0, which is something that could happen. It shouldn't happen, but it could happen, and we want to clamp that at our max power. So we're going to go between 0 and, in this case, 2. 2 is our max power with this guy. All right. And then we're going to take the launch vector and we're going to feed in our anchor direction, which is pretty straightforward. We want to be able to move in the direction of our anchor. Yeah. And that is basically all the information we need to feed in the trajectory calculator, because, again, all we need is the power and the direction, because we already have gravity figured out. We already have drag figured out. Those are constant values. So these are the only two unknowns. And we feed those into the calculator and it generates an arch. The next thing we want to do is we want to use the information we gathered from that arc to display it to the player, right? We want the player to be able to see that, to see some sort of visualization that shows them where the object is going to go. So that's where this is. So if our display isn't null, because we don't want to do anything if we don't have a display hooked up, then we want to get that path. Hey, this is where we're using get path. I remember in the last episode how we couldn't delete get path because we were using it somewhere. Yeah, this is where we're getting it. So I don't know if I've ever talked about line renderers before. I'm gonna minimize this guy for a second. This is a line renderer. A line renderer is very, very straightforward. It generates some polygons and applies a shader to them based off of. So here we have, let's do 1, and then we'll do 1, 1, then we'll do 1, 1, 1. All right, so this is our line renderer. And right now I have this thing set to world space, and it doesn't receive shadows or cast shadows because it's kind of like a UI thing that I'm using it for. I gave it a material that I'm using. I called it Arrow Matte, even though I probably shouldn't have. It's just using a black 2x2 pixel texture that I put in here because I wanted it to just be black. And I am setting the initial color to full white and full opacity, and the end color to no opacity and full white, so that it'll fade off in the end. That's kind of what's giving it this faded look. I did that so that you don't see if you see the end of the arc, like if it comes up and then comes down, you don't just see it harsh cut off. It looks kind of tacky. So I made it fade off like that. Now a line renderer is really straightforward. You feed it a list of materials just like any other renderer. You tell it how to use lighting if you want it to, and then the series of positions are the series of positions that it uses for the center of these points. So like the center of this edge right here is the first point. So that's 1, 0, 0, right? So if I change this to 0, 0, 0, you'll see that that is the world origin, and then it comes up here to 1, 1, 0, and then it comes over here to 1, 1, 1. Yeah, and then we have a width and we have an end width. So if I set the end width to 0, it will taper off. And I've actually been considering keeping it like that. I don't know though. If I set this to 0.2, it'll be thicker in the beginning and then taper off to nothing in the end, like so. And then do we want to use world space or do we want to use local space? This just tells it where to be, I guess. And actually, we probably shouldn't have this at some weird position. We should probably have this at the object. I don't know why I had it way over there, but it doesn't really matter because I was using world space. So this is basically the entire thing of a line render. It's just render a line, and these are the points. That's all it is. So I'm going to leave it at that, and I'm going to save the scene because I want to keep that information. And back to our script here. So again, we want to get our path locations, and we want to feed those in to our line renderer, right? We want our line renderer to follow that arc that we've already created. So we're going to set the vertex count to be the length of our arc, our different points on our arch. And then we're going to go through each point on that arc, and we're going to set its position to be the position in the arch. So yeah, set vertex count is how you set the length of the line renderer list. This guy, the positions. Set vertex count is how you set how many of those there are. and then set position is how you set the position. So the first variable being the position you want to set, and then the second being the position that you are setting that position to, if that makes sense at all. So this whole thing right here, it creates our visual arch if we have one hooked up to the controller, which is here. So if I select this, no, sorry, this, it will display my arch display. Cool. I have a little bit of debug information hooked up to this thing. I don't know. I did have it on. I can show it to you guys. If I do this. So I've disabled the arch preview because we don't need that right now. So if I drag off of it, you'll see that red line appear on the top. That is actually a line that's going from where I clicked to where I... Actually, that's the power. Yeah, that's what that is. That's the power and direction that I'm going off of. So you'll notice that it actually... it is, I guess, a tangent of my arch. So, like, I wish I had two cursors, then I could point to two things at once. But basically the gist is the line coming off of that is, if you follow that straight, it like wilts, right? It, like, that line is what starts my arch line. Yeah. So hopefully that makes sense. But that's what the debug does. It just renders the direction to my my cursor. It's like the power and stuff like that. So what I want to do is I want to do this though, because this is actually going to give me, I don't need those parentheses. What this is going to give me is my actual power that I'm inputting. So that is importing down here, or rather compiling. And now it's done, and now I'll have a shorter red line, and that red line is actually going to be the red line from where I clicked to my cursor. So that's the distance that I'm getting. That's a little bit better information for me. And you'll see that tapering that I just added to the line renderer is carrying through, and actually I think it looks a lot better as it is now. So yeah, because it kind of like is an arrow pointing to the thing, pointing to where it's going. Yeah. Anyway, going back to this. So this is if we have our mouse down currently, like if we're holding the button down. But if we are anchored and we do not have our mouse, or if our mouse button is up for that frame, so as soon as we let go of the mouse, we want to fire the object. We want the projectile to go. So that's a whole nother class down here. But the thing that drives this whole thing is when we click on something. So this OnMouseDown class is, I believe I've talked about this in my input videos and stuff like that, but the OnMouseDown function says that if you've clicked on this object, so if you look at our launcher object, it actually has a box collider on it, even though it's not a box. And it has that box collider on it because, and then it's the reason why it's tagged with a launcher layer, is because it needs to have a box collider on it to function in the way that we need it to, because it has a mouse down function on the class that reads that collider and sees if we've clicked on the object. So as soon as we clicked on this object, we want to set our anchor position as our current mouse position and then set the anchor to true. And then once we've done this, on the next frame, if we've let go, we fire the object. So if I just tap on that guy, it'll fire, which is something you may or may not want. Maybe you do want that. That'd be weird. But if I just click, it will fire an object. Yeah. So maybe you do or don't want that. Maybe you only want it to fire a object if you're over a certain power. If that's the case, then it's easy enough to do that. You can just say if tcalc.power is greater than or equal to, say, 0.5, then fire the object, right? So now, in theory, if we come back here, which, by the way, I don't know if you noticed that, but I'm doing some fancy like space saving trickery going on here. So I have an if, and then I don't end either of those ifs. Like they have open brackets, but they don't have open brackets or anything because I'm just doing it all in line. That's the thing you can do if you didn't know you could do it. It saves a lot of space and saves a lot of, like, I'm doing two pretty simple calculations there for if checks. So now it won't actually fire the object unless I have a power of at least 0.5. So now I can't, if I click on it, this thing doesn't go away, which is unfortunate. But yeah, so that's kind of a thing. I can have that, because firing the object is what disables my display, so I want to move that. Whoa. So maybe I do want this to be like that, and I want to say if trash display does not equal null, it's not equal null, then that. Okay, cool. So now when I click on it, it won't keep that trajectory display around. No, oh, stop it. Oh, stop it. I capitalized it, didn't I? Oof. There we go. That's better. Okay, yeah, so now when I click on this, it won't fire or do anything until I click and drag a certain amount. Yeah, until I click and drag a certain amount off of it. And if I like bring it back to there, it won't fire an object. It won't fire an object until I get it to there. And we can do a little bit more trickery to make sure that, like, you know, you take this exact same if statement and wrap it into here. And now we won't even get a display of that trajectory until we have a sufficient enough power to do something about it. So now if I click and I drag, eventually I will get that, and if I click back in here, it'll stop updating the display, which is bad. So we need to go in and tweak this more. If that, else if has display is not whoa. Not null, then we want to do this guy here. Yeah, cool. So this is going to make the thing go away whenever we can't. If we can't fire a projectile, then we won't see the display that says that we can. That's textbook 101 messaging to the player, is if you're telling them they can do something, then you have to be able to let them do something. So as soon as we pull that in enough, we don't have a sufficient enough power, we won't let them fire, and we won't show them that they can, right? If your game has bad messaging, it's a bad game in my opinion. So yeah, this actually lets you, this is a much better display system than I had before. Oh, I'm pretty happy with that. All right. So anyway, yeah. So that handles our display, and then the firing of the object is just like it zeroes out our anchor position and our direction and our distance and the power and the launch vector and all that stuff. It just zeroes everything out, and then it makes it so we're not anchored anymore because we fired the object. We're purging everything. We're purging all of our stored data, and we're creating the projectile. And now the projectile, if we're doing all this in the same frame that we have already created the arc that we need, so the arc isn't going to go away quite yet. It's going to go away at the end of this frame. So right after this, we create our projectile, and we store it locally as a game object, which if you've ever instantiated something, if you've ever instantiated a game object like a prefab before, which we've done before in a previous video. We did that in my first-person shooter-y video kind of thing. So go back and watch that if you don't know what I'm talking about. But if you've ever instantiated an object and you want to be able to control that object afterwards, this is the way that I've found to do it. So you do your instantiate object, but you do an equals, a game object name of the game object equals it first. So you're storing this as this object, and then you do as game object at the end, and it'll convert the object, which is really, really vague, but that's what this creates. Like if you look at the completion text, it actually creates a public static t instantiate. So yeah, okay, so here you go. So public static object instantiate. It creates an object, which is really, really vague, but an object isn't a game object, so it can't be used as such unless you convert it as one, because they're basically the same thing, so they can be converted back and forth between each other, but you have to do that. And that's kind of what I'm doing here. Is I'm saying, hey, make me an object, but treat it like a game object and let me store it as one. And it goes, okay, I can do that. So that's kind of what I'm doing here. And then I'm telling it, I'm initiating it with the trajectory, which this line is really important, and we'll talk about that in the next video. So remember this line, and I'll probably bring it up in the next video as well. But this is where we create the projectile object, which is our prefab that we have stored here, or on our launcher. That's where we have it stored here, which is this guy. So we have that, and we're instantiating that at our position. We're giving it a quaternion dead identity for rotation because we don't care about that quite yet. And then we're feeding it the trajectory to figure everything else out on its own. And then we're just kind of stepping back and letting it do its thing. So we're purging all of our data, and we're giving it the trajectory, and we're saying, go projectile, go, do what you need to do. Which may or may not be the right thing to do, but that's kind of how I handled this. So hopefully this makes sense. And yeah, so now we have our controller and our calculator. And you can kind of see how they play back and forth with each other, how the controller interprets the mouse inputs into power and direction and feeds that into our calculator to generate the arc that we need. And then we give that arc to our projectile, and in the next episode we're going to be talking about how that projectile moves along that arc and how I managed to solve my subdivision problem in the projectile with smoothing the movement of it, and how it handles all of its explosions and all that stuff too. So that should be a fun capstone to this this 3-part series, or 4-part series, I guess, because the first one was kind of a mess. But yeah. So anyway, thanks for watching, and I'll see you in the next video. Bye bye.